Hi, Databricks community. In the previous session, I had spoken about the Spark architecture, wherein I discussed what is Spark master and what are the worker nodes and the executors. I had explained that whenever we are executing the Spark application, the application is broken down into jobs. The jobs are further broken down into stages, and the stages are broken down into tasks. Today, let us try to understand this split up with the help of few examples. Uh, to understand it, let us take a look at the Spark ecosystem. The Spark framework is being built on top of the Spark core. And Spark core, we have Spark SQL, Spark streaming, machine learning related, and graph data processing related modules. So, from the PySpark perspective, being all these written in Python, I can say Spark code is one module, and Spark SQL is another module, streaming is one more, and so on. So now these SQL streaming all are built on top of the Spark code. And as you know, to work with Spark code, we can use any of these languages, R, SQL, Python, Scala, Java. So, but then, what's the meaning of working with Spark? You can work with Spark at these different levels. You can work with Spark at the Spark core level, or you can work with the Spark at the Spark SQL level and the streaming level, right? But then Spark core is a very kind of low level framework that we have it in hand, and the developers may feel steep learning curve to work at this level. The API is little complex. The API which we get to work with here at the Spark core level is RDD. Okay, so we are going to work with what we call as RDDs at the Spark core level. As it is low level and it is a core API, most likely data engineers they tend to work with the Spark SQL or the streaming level. So this core level is meant for handling any kind of data, structured as well as unstructured data. You can handle it here, right? But we do have better ways of handling the structured data in Spark. That's nothing but using the Spark SQL and Spark streaming libraries. If at all you happen to have unstructured data, only option that we have is to pick RDDs to work with. Otherwise, if it is structured or semi-structured data, we can go with accessing the APIs at the Spark SQL or the streaming level. So while working at the streaming and the Spark SQL level, the data abstraction that we are going to use is data frames. So if it is Spark core, we'll be using RDDs. If it is Spark SQL or Spark streaming, we are going to use data frames. Now, I will be showing a couple of examples using the RDD so that you will be understanding how the jobs are created, how the stages are created, and this task thing. I happen to launch here the Spark standalone mode. It is installed on my system. And over here, I have launched interactive shell, just like how we get Python interactive shell. For working with PySpark, we do have the PySpark interactive shell. Given Spark is installed in your system, you just have to simply say PySpark here, and then that's going to launch you the interactive shell. Here you could see that internally we are depending on Python 3.11. Fine. Over here, what actually we launched this one interactive Spark application. And this interactive Spark application has a name, and it has certain things already created for you. And you could also observe here the web UI is available at so and so port number. If you happen to look at that, you could see that okay, uh, we have one application running. A particular name is not given. It's given actually. It is PySpark shell. Name of the Spark application that we are executing is PySpark shell, and its application UI is available here, so that you get to check how many jobs are created in your application, how many stages, and so on. Right. As of now, if I happen to open this event timeline, we have nothing. over here because we don't have any jobs, right? We don't have any jobs. Coming to executors part, if we check it, let it load. Here you could see that we have just one driver because everything we are running in the same machine itself. Okay, just the driver node we have it, and it has a four CPU cores. So this is what we have. Just one, on the driver itself, we are simulating everything. So this is the case. Okay. Next up, let us see when will we get jobs listed over here. Here I go about creating RDD. RDE stands for Resilient Distributed Dataset. This stands for Resilient Distributed Datasets. Okay, they are the abstraction. Spark Core API. This is Spark Core API. So how do we create them? If at all you are finding it hard to understand what these RDDs are, you can compare or maybe try to understand from the programming language that you already know. For example, let us say you know Python. While working with Python, you create a variable so that that variable can store some number, a equals to 10 or so. Likewise, you can create some other variable x, and that variable may contain, okay, a list of numbers, right? So this way, this variables and the integer scalar values are helping us to hold on some data. So this list is helping us to hold on some elements. Now, given that x is pointing to the list, we get to use some methods from the Python, maybe to add some more numbers onto it or remove something from it and so on. So likewise, uh, Python has certain frameworks called pandas and all. Okay, pandas framework is there. In this Python framework pandas, we get to create what we call as data frames, just like there are lists in normal Python. So in pandas, we have option of creating the data frame, and that data frame is something similar to table actually. Okay, table of records, wherein the columns will be there, rows will be there. But these data frames that you create, they are going to be lying on the single machine itself. Okay, they will be lying on the single machine. But then when you happen to create your Spark related things, right? Spark related. In Spark, you can create RDDs and you can create data frames. So these RDDs and data frames, they are not going to lie on single machine. Instead, they will be distributed across the machines. So that is the difference. Since these data collections will be distributed across the machines, they will help us doing the parallel processing. So that's the case. So we are creating such kind of thing now, RDD, resilient distributed data set. And these resilient distributed data sets can be created from the Python list, okay, dictionary, sets and all, or otherwise we can create them from the files as well. Okay, we can create them from the files as well. But then here to show you the example, let us try to create the RDD from the list. Okay, I will say we have a Python list 1, 2, 3, 5. So this is my list. So out of this list, I will try to create the RDD. So RDD 0. So I will say, sc dot. What is this sc? It is the Spark context. It's available here. You can see for every Spark application that you are going to deploy on the cluster, you have to initialize a Spark context object. This Spark context is going to act as entry point into your Spark application execution. Just like in programming languages, we will be having main method as the entry point. So likewise, in the Spark context is the entry point, right? So it's going to be only one object for the entire application. So we are going to create such kind of Spark context object, but in this interactive environment, it's already created for us. And with the help of that, we can call a method by the name parallelize and pass on the list that you created. So this is that simple. The RDD is created for you now. But how do I get to see the contents of the RDD? I would like to print it and see it. So if you simply say your RDD 0, it simply says that it is a kind of RDD, right? Python RDD it is. But if I say L, see it is rendering, right? L is a list. It gets rendered, but your RDD is not getting rendered. It's not getting printed onto the screen. Okay, because there is some reason to it. Uh, Spark being the in-memory data processing engine. Okay, certain things are lazily evaluated. The contents of the RDD are not pulled down simply onto the screen or the memory unless you actually want to see the final outcome of it, right? So why are we creating RDDs? We are creating RDD so that we can perform some data processing on top of it, right? So you have to create the RDD, you have to perform the data processing, and finally you have to say, I'm done with applying the data processing logic. Now I would like to see my data. At that time only, entire operations on your RDD will be executed, right? For example, in this case, this is the list we have, right? Let us try to increment each of the number, okay, by one. So for that, I have to write some sort of logic on top of this RDD, right? So that's nothing but let us create a new RDD, okay? That RDD will be derived from the existing RDD. RDDs will be having the methods to work with, which we will discuss later, okay, in more detail. So there is a method called map available on the RDD. So to this, you can pass lambda as expression, and you can say pick each of the element in the RDD and increment it by one. So this is going to render you the transformed RDD. The RDDs are immutable, just like strings. So whenever you are performing something on the original RDD, it will be okay, resulting in creation of the new RDD. You can see that here. So RDD1, again, if I try to print also, it's not getting rendered because all these are lazily evaluated. Fine. Spark engine is just going to remember, okay, what kind of instructions we are giving to it. And all those instructions will be executed, okay, when you want to finally see the result. For example, now I would like to see the result. Okay, I have already transformed my data, incrementing each element by one. I would like to see my result now. So how can I say, do we have print for that? No, we don't have something like print. We have something called collect. Okay, or we have something called take. Fine. So RDD1 dot collect, let me say. So this is when, right, finally I would like to collect the outcome present in the RDD. So at that time, you are, okay, see, it gives some logs like, stages being happened and you got the final result. Now let us visit our web UI. So here let us refresh the page. You get to see there is one completed job. If I scroll down here, you could see this is a job with the ID 0. It got created because I called for collect. Okay, and it took 3 seconds of the time to get executed. And this job is broken down into one stage, one by one, right? So one stage and one stage in total, one stage succeeded as well. And this stage is further broken down into tasks, right? For all stages succeeded by total 4. So one job broken down into one stage and 4 tasks. Why 4 tasks? It's because as you observed in the executors, we have 4 CPU cores. 4 CPU cores. Because of that, 4 tasks were created. Okay, this is what I was mentioning previously. Application, it's broken down into jobs. The jobs are broken down into stages, and stages are broken down into tasks. And these tasks are something, okay, executed by the executors, okay, inside the cluster. And executors will be having most likely one CPU core or so, right? So finally, number of tasks will be equal to number of CPU cores available to us in the cluster. Okay, that's a case. That's how you got it. Now let us see the example of maybe, right, uh, collecting or creation of more than one stage kind. So this already one itself. So let us check what can we do here. Yeah, RDD1 dot reduce I will call for. Yeah, RDD1 dot reduce, and I will say lambda. Okay, let's come away. and then say x plus y. So it gave the result to us, right? It gave the result to us. It calculated the sum of the numbers and we got it as 20. Now let us see what's happening here. It is okay. See one more job created for reduce job ID, and still it is going on for one stage itself because we have the things in one place and so on. Okay, for the iterate, we just have it as one itself. Uh, in my next sessions, maybe right. Let's take a look at when it will result in creation of more than one stage. I will give you a conceptual idea in this clip itself. See, basically what's happening whenever we have taken the no, numbers, for example, let us say apple, apple, okay, ball, bat, cat, okay, like that. We have certain numbers. If you would like to count the number of occurrences of the words using the Spark, right? Let us try to create the RDD out of it. After creation of the RDD, it may happen that the apple and ball are going to one task, bat is going to one task, cat is going to one task, and this other apple is going to one more task, right? So they are on different machines, right? This is on one machine. These two words are on mission. Bat is in one more mission, and cat is in one more mission. So when I happen to write the logic of, count the number of occurrences of the word, so I have to do the group by first because we don't have all the numbers in one place, right? All the words in one place, we don't have it. So that's why we have to group by, right? So some sort of group by, action or logic we will be invoking. So at that time, what will happen? The shuffling of the data takes place, right? The shuffling of the data takes place. I hope I have explained it I did to you with the help of an example. Okay, so it was there in my, I think, earlier video. You can check it. Fine. So the data exchange has to happen. Now we have to bring together the apples, right? And we have to bring together the maybe right the words with the okay, ball as a text, cat as a text, and so on, right? So this is where exchange is happening, right? Exchange of the data is happening between the machines. So at that time, whenever the data exchange happens between the machine, the stages are created. So number of stages, okay, equals number of stages equals to 1 plus the number of exchanges happening in your logic, right? Number of data exchange that will be happening in your logic. So this will be the equation for number of stages created. In our case, what happened when I did RDD dot reduce, so data exchange was not required. Okay, data exchange was not required because they did okay, whatever numbers were there at that place, they did it, and they finally gave that summation to the driver kind, right? Data exchange was not required. It was kind of an associative and cumulative logic that happened there, the summation one. So that's why the exchange was not required, and in one stage the things happened. So this is the case. We will see further details upon uh, okay the type of logic that may result in creation of more than one stage and all, right? So this is where we have to discuss about the kind of operations we can do on RDDs. The narrow transformations and the wide transformations. Okay, so all these we will discuss about in the upcoming session. So until then, you can right try understanding the concepts discussed over our previous sessions and all. Thank you. Stay tuned.